So now today we are going to find out the range of repulsive interaction. So in the previous lecture we have deduced that your cohesive energy for ionic crystal is made up of two terms. So this term represents the center field repulsive potential, and this represents the Coulomb potential energy. Because this term represents, or this is originated due to the fact that the ions cannot overlap each other's electronic distribution, because as long as they are apart, there will be no overlap of electronic distribution. So if they are going to overlap each other, then they have to overlap their electronic cloud, or you can say electronic distribution. So therefore, due to the Pauli exclusion principle, there will be electronic repulsion. So therefore this is originated from, that is, Pauli's exclusion principle. So now here this term is known as the range of repulsion, and this represents the strength. Lambda represents the strength. So now in this lecture I am going to deduce the value for your range rho. So now this range rho of the repulsive interaction, this can be obtained from the measurement of the compressibility of the crystal. So thus in order to find out the compressibility of the crystal, we have to know about the bulk modulus of that particular crystalline solid. So now from the formula we know that the bulk modulus of solid is given by, this is given by K, and this is equal to minus the change in pressure divided by the volumetric strain, and the volume strain represents by the change in volume divided by the original volume. So this is the formula for your bulk modulus: change in pressure divided by the volumetric strain. Volumetric strain is the change in volume divided by your original volume. So now, thus since we know that the compressibility is basically the reciprocal of your bulk modulus. So thus your compressibility is 1 by bulk modulus, the reciprocal of bulk modulus. So this will be minus 1 by V. So this will be reciprocal d V upon dP. That is the change, the rate of change of volume with respect to pressure. So now suppose this is equation number 1, this is equation number 2. So now from first law of thermodynamics, that is change in heat is equal to the sum of change in internal energy plus your mechanical work, that is P dV. This is mechanical work. So now for adiabatic compression, that means there is no exchange of heat. For adiabatic the change of heat is equal to 0, means heat remains constant in adiabatic pressure. So therefore change in energy, that is internal energy, is given by, so since from this equation you can also write that du is equal to dq minus P dV. So the change in energy, internal energy, is given by, this will be 0, this will be minus P dV. That is mechanical work. So now since we have to find out this factor, so you can, so from here minus P is equal to du upon dV. So now I have to find these factors, therefore differentiate this with respect to V, therefore this will be dP upon dv, this will be minus du on dv स्क्वायर. इसको मैंने v से फिर से डिफरेंशिएट कर दिया. So I have calculated this factor in terms of your internal energy. So this is equation number 3. So now putting this equation into equation number your 1. So thus your equation 1 can be rewritten as that is k will be v minus minus cancel, v into du upon dv square. This is equation number 4. So now since if you take sodium chloride, for sodium chloride structure, because this is ionic solid, so this volume will be, because this has FCC structure, so volume of cube is equal to the cube of its side. That is since if you write in terms of your nearest neighbor, so this will be capital R cube nearest neighbor distance, and let capital N be the number of your atoms in the crystal, ionic NaCl crystal, and multiply by 2. So this is 2 because the contribution to the volume is coming from the both sides, that is positive and negative ions. So therefore this will be 5. So this is the volume of NaCl crystal, where R is the nearest neighbor distance and N is the total number of molecules or atoms in the your NaCl crystals. So now I have to find this du upon dv. So first of all, the rate of change of internal energy with respect to volume du upon dv, इसको मैं chain rule of differentiation लगाऊंगा. So this will be, because r is here, उसको मैं ऐसे लिखूंगा du upon dr into dr upon dv. This is the chain rule of differentiation. So now मुझे चाहिए double derivative. So now differentiate again with respect to volume, it will become, so now it will be differentiated double by with respect to v. So now product rule of derivative, this will be first function differentiation of second function. So this will be dr to dr square dv square plus this will be differentiation of first function d and this will be, sorry, this will be dr, this will be dv into dr into dr into dv, because this was dr upon du upon dr, so this will be d square u into dv into dr, because this is double derivative. So now what I will do to simplify this, I will multiply and divide here by dr. So now multiply and divide करके क्या आएगा, this will be, this equation will be reduces to, this will be same du upon dr to d square r into dv square plus du, this will be dr square into dr upon dv, and this will be dr into dv, dr into dv, this factor, and dv will be here, so this will be dr into dv. तो ये हो जाएगा इसका होल स्क्वायर. So this we have calculated. So now this is equation number 6. So now, since I have calculated what is the volume of an NaCl, this is 2 r cube. So differentiate this with respect to r. This will be 6n r square. Since I have dr upon dv, so its reciprocal will be dr upon dv will be 1 upon 6n r cube. So now this I have the value. Since in the physics we are more interested about the stability, so we will calculate this will be at equilibrium. So therefore at equilibrium your equation number 6 becomes, or you can say at equilibrium your r upon r will be r naught, and your du upon dr will be 0, because slope will be 0 for stability, for minimum energy. So this will be 0, so this term will be equal to 0, and we will put this value into this equation. Therefore the equation 6 becomes at r is equal to r naught, so d square into dv square will be this term will be 0, because this is equal to 0, so this will be d square du upon r square, and we will put this value square. So this will be 1 upon 6n r square ka whole square. R is equal to r naught, this will be square, so therefore this will become du upon d square, this will become n square r naught 4, this will be d square or d r square, r is equal to r naught. This will be the equation. This is equation number 7. Now by using equation this 7 and 5 into equation number 4, we will get, that is bulk modulus is equal to, that will be volume की value है 2nr naught cube into this du square dv square, this will be 1 by 36 n square r naught 4 into d square u on dr square r is equal to r naught. So this will be cancelled, this and here this will be also cancelled, so k will be 1 upon 18n r naught d square u on dr square r is equal to r naught. This is equation number 8. So now, since from the previous article I have calculated that du total upon dr is equal to minus n lambda z exponential r upon rho plus n alpha q square, this is divided by rho, this is divided by r square. So now double differentiate, because I have to find out this. Double differentiate this with respect to r, du total dr square, this will be, this is constant, this will be, this is the argument of z r, this will be 1 upon rho, so it will be minus n lambda z divided by rho square, this will be exponential minus r upon rho, this will be minus n 2 n alpha q question number 9. So put this value into this equation at r naught. So r will become here r naught. This will be r naught. This will be r naught cube. So now this is the resultant equation by putting the value dv square u total upon dr square. So now this we have also calculated this value in the previous lecture. So now since we know that exponential is minus r naught upon rho is we have calculated, this is equal to rho alpha q square upon z lambda into r naught. So there was another factor to 1 by 4 pi epsilon naught, but that was in SI system. So in Lorentz heavy side system, your epsilon naught is equal to 1 and 4 pi factor dissipates. So thus this is in CGS. So in SI this was your 1 by 4 pi epsilon factor was there into CGS system. So 1 by 4 by epsilon factor is neglected here because this is considered in your CGS system. So now putting this value of this factor into this equation, thus therefore resulting equation bulk modulus is equal to 1 by 18n r naught into n lambda z rho square. This will be multiplied into rho alpha q square z lambda r naught to minus 2 n alpha q square divided by r naught cube. So now by solving this, so we will get 1 by 18 n r naught lambda z cancelled. This will be rho also cancelled here. So this will be n alpha q square into lambda also cancelled. This will be r naught to rho minus 2 n alpha q square upon r naught cube. So now here now if you want to further solve this, what you will do, you will take this as your common. So now you will have, so now here there is one mistake, there is r square, r naught square, this is r naught square. So now in order to make this, sorry, this is square, in order to make this cube, because I have to take its column, r naught will be multiplied by here. So I'm taking this whole factor as a common, so you will have n alpha q square to 18n into r naught cube. This will be r naught 4, and here this whole this row is here. This make it as a cube multiplied divided by r naught. So this will be here and this will be minus 2. So n cancelled. So this will be alpha q square 18 r naught 4. This will be r naught upon rho minus 2. This is bulk modulus. So now you have to find a rho. Take this factor and take this factor to this side, and 2 will be here, or write this r naught upon rho minus 2. This will be 18 r naught 4 into k divided by alpha q square, and r naught upon rho will be 18 r naught 4 into k divided by minus here will be plus. So this is your equation number 10. So that's from equation number 10 we can find out the value of this rho if we have value of r naught, k, alpha and q for the given crystal.